guys, we are going to calculate the mean, which is the expected value for and standard deviation for discrete random variables. Then we're going to talk about transformations and combinations. So first thing that you need to know is in this chapter, rather than using the word mean, a lot of times I use the word expected value. So if I say calculate the expected value of x, that's the mean. Write that down. Mean and expected value are the same thing. Okay, so this is the first example that we are going to do. Microsoft Word no longer has mu or sigma, so all of my variables turned out wrong. Your variables are correct though. So here I have an m, you should have a mu. Here I have an s, you should have a sigma. I have an m, you should have a mu. We do? Of course. Okay. So the first example, we are looking at the number of whole chocolate chips that come in mini Chips Ahoy. So there are no whole chocolate chips in about 5% of mini Chips Ahoy. There's one whole chocolate chip in about 65% of Chips Ahoy, etc. So there's the table. This is the histogram that shows that data. I don't know if this is real data or not. Okay. So we're going to start by calculating the mean and the standard deviation. I would like to know the mean of the distribution. So the first thing that you have to do is you have to write down the formula. Okay, here's what this formula means. Take each x value, multiply it by its probability, and then sum them all up. So the first x value is 0. That probability is 0.05. And then I have 1 times 0.65. And then 2 multiplied by 0.2. And 3 multiplied by 0.1. That ends up being 1.35 whole chocolate chips. So on average, we expect about 1.35 whole chocolate chips in mini Chips Ahoy. Don't round up. You can't have 1.35 whole chocolate chips, but you leave your answer like that. Then I want to know the standard deviation. So we're going to use the other formula. The formula is for variance, so we're going to have to get our answer and then take the square root. So you're going to write your formula first. So here's what this formula means. Take each x value, subtract the mean, square it, and then multiply by the probability. So I have 0 minus my mean of 1.35. I'm going to square it and then multiply by the probability. And keep going. I didn't calculate that, but I did take the square root. So the standard deviation is 0.726. It's supposed to say chocolate chips. So that's the typical deviation from the mean. Alec?
The longer ones, can we just write the first one, then dot, 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 the last one?
Yep. So do we all understand how these formulas work? Yes. Do we want to know how to do this on the calculator to make it faster?
Yes.
Okay. We're going to do the calculator with the next example, though. So for this next example, we are looking at the New York Lottery Quick Draw, which is called Keno. So W represents the player's winnings. So the way this game works is you have 4 numbers. If you match none of the numbers, you don't win anything. If one of your numbers matches, you still don't win anything. If 2 of your numbers match, you win $1. If 3 of your numbers match, you win $5. If all 4 match, you win $55. And you pay $1 to play the game. So we want to know the mean and the standard deviation. We're going to show the work and then do it on the calculator. So the mean of W in this case, you're going to show me the formula. So it's W times P of W because we're looking at winnings now. So instead of X, I'm doing W. Okay, so the first W is 0, and that probability is 0.30823. And then, like Alex said, do plus ... and then do the last one. So the last one is 55 times 0.003063. And then you're going to go to the calculator. First thing that you want to do in your calculator is put all of the W's in list 1. Now, if all the W's go in list 1, all the probabilities go in list 2. Be careful because these two W's are both 0. So you're going to have to add those two values. Yes. You can do them as two separate. I just added them together. If you do them as two separate, it'll still calculate it correctly. Okay. So then what you do next is you go to 1var stats. So that's stat, go over to calc. And then you need to put list 1, comma, list 2. This is telling your calculator that my variable is in list 1 and that the corresponding probabilities are in list 2. Now, if you have the new software, you enter list 1, and then on the next line it asks you for frequency list. That's list 2. So list 1 and then list 2, or you do the comma if you have the old software. And then hit enter and you should get what I got. Okay, did we all get the same thing I got?
Yeah.
No, you did not?
My X.
Yeah, S is always round.
Yeah, I think you go a little bit off from mine.
Yeah.
Did you get the same X bar?
Well, it's a little bit bigger.
Like how much
Or no,
bigger?
Sorry, it's 0.59719.
That's fine.
Yeah, mine are like. Mine aren't that much off, just a little bit.
Yeah, and
Okay, but we all got about these values?
We
Yes.
rounded the third decimal place in there.
Okay. This is our X bar. So our expected winnings are about 60 cents. So we expect to win about 60 cents. And then for standard deviation, you're going to do variance instead. So make sure you show the formula. Show the first substitution, the last substitution. You can do ... in between. So the first X value was 0. And then if you remember, the calculator always shows you standard deviation, not variance. The formula is for variance, but we get standard deviation off the calculator. Now, if you remember, your calculator has two different standard deviations, S and sigma. Which one have I always told you to use?
Sigma.
No, S. I've always said use S. I said there's one time where you use sigma. And this is the only time where you use sigma. And it's obvious because it doesn't give you S. So our standard deviation is $3.19. And if I asked you for the variance, you would just square that from the variance. Question on the calculator or either of these two formulas? No? We're good? Okay. Flip the page. This is the example you have on the next page. Okay, so this would be an example of a continuous distribution. So if I said the heights of American women are normally distributed with a mean of 64.5 inches and a standard deviation of 2.5 inches. If I asked you for, okay, if I gave you the distribution and I asked you for the mean and the standard deviation, these are the two formulas that you would use. What changes is instead of summing up, you're taking the integral. So you integrate instead of summing. Because this is calculus and not all of us have taken calculus, you will not do continuous distributions at all. You're only going to do discrete, which we just did. But if you go on and take stats in the future, it involves calculus. Okay, this is where it gets more difficult. So now we're going to talk about transformations and combinations. Okay, so first of all, a transformation is when a new random variable y is created by adding and or multiplying the old random variable by constants. Okay, so this is our formula. I have this random variable, I multiply by a constant and or I add a constant to make a new variable. I'm going to ask you what's the mean and the standard deviation of y. The mean of y is really easy. All you do is substitute the old mean in. So whatever the mean of x is, you substitute into your equation, that will give you the mean of y. Standard deviation is more difficult. Actually, you find variance of y. If I add a to every observation, so I add some constant to every observation, it doesn't change the spread at all. So all it's doing is taking your observation and then you're sliding it over. It doesn't change the spread. But if I multiply everything by a constant, that does change the spread. So b is going to affect the standard deviation, but a does not. To find the new variance, you take the variable that you multiply by, you square it, and then multiply by the old variance. That gives you the variance of y. So let's do an example. The temperature of a freezer is a random variable with a mean of 32 degrees Fahrenheit and a standard deviation of 3 degrees Fahrenheit. Find the mean and standard deviation in degrees Celsius. Okay. Do we know the conversion from Fahrenheit to Celsius?
Yeah.
What is it?
5 nines plus 32. Or the other way around or something.
Okay, so we're not really very confident.
Let's hear it.
This is the one that you guys know, or that you have seen.
Yeah.
Right? 9 C plus 32. But we're converting Celsius to Fahrenheit. So you need to solve for C. So it ends up being 5/9 F minus 160 over 9.
That's nice.
So this is a transformation. I'm transforming Fahrenheit into Celsius. I am multiplying by a constant and then I'm subtracting a constant. So we need to find the mean in Celsius. All you just do is plug in the old mean. So I do 5/9. The mean in Fahrenheit is 32 minus 160 over 9. You guys have a guess?
I can't see.
0.
I can't
0.
Oh, wow.
Okay, Alex, how would you like me to help you?
I don't see this.
Would you like to come
Sit right
sit
there,
here?
No.
Would you like to sit there? Would you like to sit there?
Do you want to trade spots?
Can I sit on the table?
On this? Absolutely not. Anything else?
No.
Okay.
These for spots.
Okay, now we have to find the variance. It asks us for standard deviation, but we use the variance formula instead. Okay, so it's b squared times the variance in Fahrenheit. Okay, b is the constant that you multiply by. So this 160 over 9 doesn't affect the variance, doesn't affect the spread. The 5/9 does. So you take the 5/9, you square it, and then I gave you a standard deviation of 3, so you have to square that to get variance. That means that the variance in Celsius is 25 over 9. When I square root that, I get the standard deviation in Celsius to be 5/3. Not too bad. Could be worse. Okay, good. That's a transformation. Combination on the right side is when a new random variable, I'm calling it z, is created by adding or subtracting two or more other random variables. So in this case, I'm adding or subtracting my two variables x and y, and I'm making this variable z. Mean is easy to find. If you do x plus y, then all you do is add the means. If your formula is x minus y, then you just subtract the means, and that will give you the mean of z. The variance is more difficult. First thing, it's always adding. And then you add variances, not standard deviations. So pretty much I'm always going to give you the standard deviation. So you have to find the variances and you add them. Even if your formula is x minus y, you still add the variances. Think of it kind of like the Pythagorean theorem. But that should make sense. If I have two random variables that I'm putting together, the spread should always get bigger. That's why you have to add the variances. It should never get smaller. So the example that we have, it says 4 members of a 4x100 relay team had individual lap times as shown below. Find the mean and standard deviation for the team total. So first thing is I want you to write a formula. So I'm going to do it over here so that I have more room. But I'm looking for the team total. Team total is going to be runner 1, add runner 2, add runner 3, add runner 4. The mean of the team, I just add the means of all the runners. So again, I want you to show formula substitution answer. So this is 54.1 plus 54.4 plus 55.1 plus 50.2. The team average then is 213.8 seconds. So this is just saying that we would expect the team to take about 213.8 seconds to complete the relay. And now we need to find the standard deviation. You don't find standard deviation though, you find variance. So the variance of the team is going to be the variance of the runners added. So I gave you standard deviation, so you need to square all of those. So the variance of the team ends up being 17.37. So then the standard deviation of the team time is 4.17 seconds. Okay, I cannot stress enough, for combinations you have to remember that you are always adding, and it is always variance. You add variance, not standard deviation. Okay, we ready to do one more example together? Awesome, me too. It's not on here, but I think you should have enough room at the bottom of page 11. Okay, so we're going to do the top example, not the bottom one, so write this somewhere on the bottom of page 11. In November 1997, the New York Lottery promoted the quick draw Keno, so what we talked about before, by doubling the winnings on Big Dipper Wednesday. Each game costs $1 to play. So for A, I would like you to find the rule, the mean, and the standard deviation for a player's profit on a regular day. So we're going to do that one together, and you're going to do B. Okay, so our rule. So I'm looking for a formula. So what is the profit in terms of W, the winnings? So in other words, if I won $55, what's my profit? 54, right? Because I paid $1. So what's the rule then?
Winnings minus 1.
Yeah, W minus 1. What is this an example of? That we just did? Transformation, right? I'm taking a variable, I'm subtracting 1 to make a new variable. Okay, so now I need to find the mean. So I just take the mean of W and I subtract 1. So the mean of W, if I recall correctly, was 60 cents. Subtracting 1. So the mean of profit is negative 40 cents. So basically, in the long run, you're expected to lose 40 cents if you were to play this game a whole bunch of times. And then the standard deviation, except it's not standard deviation, it's variance. Okay, what is our B in this case? 1. B is whatever you multiply by. I'm not multiplying by anything, so B is just 1. So that goes away. So the variances are the same. So then my standard deviation ends up being the same also. So like $3.19. One question I forgot to ask you. For variance, why do I square it and then just take the square root? What's the point of that?
So it's not
So it's not negative.
Oh, that's what
Yeah. Okay, so that was A. I would like you guys to do B right now, please.
Big difference whether you double the process. So you still pay $1, so it's still minus 1, but it's going to be 2.
Yeah, yeah. Because like, well, the next one is the constant. I'm just trying to copy that.
Oh, we got it earlier. We got
Sorry, what?
no B squared, why does it cross it out?
Why did I cross it out?
Yeah.
Because the B was 1. So 1 squared is 1.
1 minus 2.
Because the last one was 40 cents on the break.
Yeah, but you would lose 40. 2W, yeah, 2W minus. No, it's 2W minus 4. So that would be like losing 40 cents, and this was positive. The real cost is just 1 cent.
Oh, just as
And the long one. I don't know how to do it.
More confused?
I'm struggling right now, I'm not gonna lie to you.
Okay,
Oh, it's standard deviation.
let's see how we did. What's the rule?
F minus 2W, or F equals 2W minus 1.
D, but yeah.
Same thing.
D equals 2W minus 1, because we're doubling the winnings. So then, to find the mean of D, it's 2 times the mean of W minus 1. So I got about 20 cents. I got 0.195.
Round it.
So then the variance of D is B squared. This time we have a B, it's 2. So 2 squared times 3.19 squared. So whatever that is, you're going to then take the square root. So the standard deviation ends up being $6.39.
Oh.
I use the stored values. How'd we do?
Yeah, it's not well.
To be honest, not well.
I see 20 cents.
What?
I'm confused about the first part, the mu part.
Because I did 2 times, 0.6 minus 1.
Oh, okay.
Okay. So before we talk more about this, one thing I would like to point out, over here, so on the other page with combinations, there's one thing that's really important in like future statistics classes, but we just kind of glaze over it in AP Stats. This formula only applies if your variables are independent.
Does not say that.
So the variance formula only applies if the variables are independent. I will always give you variables that are independent. I'm not going to say they're independent, but you're just going to assume them to be true. Assume them to be independent. Make sense? So just in the future, for when you hear that in your next statistics class, you're not going to be like, Miss Budden, what the heck? Okay, I forgot to leave these up here, but there was something I wanted to point out to you. Is there something that you noticed that was different between A and B? Something that was kind of peculiar? So, it was something like this. Anything interesting that you noticed? Paul?
The mean was 1/2 the opposite, and the standard deviation double.
Okay, that's true, but that's not what I want to talk about. So thank you, though. Alex?
Isn't that what he just said? Like, there's an inverse relationship.
Yes, that's not what I'm looking for, though.
So that the mean for Big Dipper Wednesday is positive.
Yeah. Yeah, that's so important. So on a regular day, you're expected to lose. You're expected to lose 40 cents on average for every game that you play. On Big Dipper Wednesday, you're expected to win. Okay, so this is why I think it's really interesting. You guys are laughing until you hear what I have to tell you.